This talk is 10 tools that complement Wireshark. Most of the time, it doesn't matter what I'm doing. I never go into a problem, whether it's solving a performance issue or security analysis, or packet analysis, with just Wireshark. There's always more tools to use out there, and I'm going to try and demonstrate why some of these other tools are superior to Wireshark for what they do, which is different than Wireshark itself, and that's why they're complementary. They should all. You should be using all the tools or Wireshark and whatever else is your favorite tool. I'm Tony Efantis, and I'm Show IP Interface Brief on Twitter. You can find me there, and I heart packets like everybody else. So again, this talk is about tools that complement Wireshark. I'm not trying to replace them. We never could, but Wireshark is great for some things. As most of you know, there's a lot of vendors out there that have complementary tools or appliances and products to Wireshark as well. So here's an example that I want to go. We're going to play a little game. Let's play What Is This? Anybody can just shout out any answer. You will be wrong. Don't worry about not being wrong. You will be wrong. What is this? Okay, pixels. I love it. He's not wrong. Okay. I can't see chat. I don't know if people are asking questions or will be asking questions, so someone should let me know.
They're posting one person said smashed Oreo.
A smashed Oreo. Okay, very good. This actually wasn't supposed to fade off the screen like that. I normally try not to do it in animations, but so I don't know what happened. I'm just going to go to the next one. That's right. It was a zoomed-in picture of the elephant. I don't know why I had to go through a few slides to get that to show up. It was a zoomed-in picture of the elephant. All right, so now you guys know how this game works. Let's try it one more time. What do we have here? Any guesses? Are there any online guesses? I want to know what they say.
A fish.
Cable going into something.
That's what somebody said.
Okay, a cable going into something, a fish.
That is a zoomed-in picture of Tony.
A zoomed-in picture of Tony. So it is a fish. Whoever that was, great. Because this is SharkFest, I chose a shark for my second image. Funny enough, though, while I was creating this little game, these little slides right here, I did try to Google like a high-res picture of someone's face, and you just get like all these women's faces, like models' faces and stuff. I was like, I better use a shark. Okay, let's try it one more time. Last round, and then we'll start some tool demos, okay? Let's play What Is It? Can you guys tell me? Right, none of you can answer this question. It's just the payload of one of the packets. But the point I'm illustrating here is Wireshark enables you to get down to the bits of packets, which is excellent. There's no tool that can do that better. But sometimes when you're so close to something like the elephant skin or the shark skin or the bits, you can't see it for what it actually is, right? It's just one packet in part of a session. Wireshark display, the packet list is called a packet list because it displays each individual packet, which can be overwhelming even on a 1 gigabit link. And so that's why I like to use a whole list of complementary tools to be able to give us some of that bigger picture of what might be going on. When I want to zoom into something, Wireshark is the tool. When I want to zoom out, I can only zoom out so far. What I mean is, if there's a simple session, and let's use this screenshot that I have here, this is one GET request to one web server. This is a single session. It has generated, 20-some packets. All right, that's a lot. But in a 10-minute time frame on a 1 gigabit link, how many of these could be put through it? And Wireshark just wouldn't be able to give you the context you need to understand what's going on that link at that time. So that's exactly what I want to show you guys here. I want to introduce some tools to you. Hopefully some you've seen, hopefully some are new to you. And this is a very famous quote. There's a really amazing author who wrote this quote, and it applies directly to what we're presenting here. Data without context is garbage. Cue the laughter. Okay, context is king. So that's exactly my point. When you're too close to the shark skin, you don't see it for a fish. When you're too close to the elephant skin, you don't see it for the elephant. And when you're too close to the bits, you can't really see what's going on the network as a whole. So here's some of the tools that I like to leverage, and on the left side, a series of tools that I like to leverage to help me in my analysis, to help me gain context about what's going on. There's lots of commercial tools out there that you can pay lots of money for to give you great context. I agree, they are great. I think everything here that I run is free and open source, except for Network Miner. Network Miner is free, but it is closed source, but you can just send Eric a message and he'll hook you up. Tell him Tony sent you. On the right side of there are just a couple of websites. That I want to demo for you guys that just help me get context around different things, or sometimes there's situations where you need to analyze packets or analyze a network, and maybe you don't have Wireshark, or maybe you don't have administrative privileges to install Wireshark, is sometimes the case as well. Okay, so I'm going to just kind of do this list as a list of demos. We're done with slides, that's it. It's just going to be a list of demos. It's not going to be super long. I don't want to get too deep in the weeds with everything, but I just want to expose you to some cool tools. So I'll swipe right. 28%, I don't think we're going to get through that. Oh boy. Okay, I downloaded the latest version of all the tools I wanted to demo, so I have them here in my downloads folder, nice and fresh. Network Miner, just grabbed it about an hour ago. Network Miner is a really awesome tool made by Eric Helmvik. I think he's presented here at SharkFest before. He's definitely presented at many security conferences. He is a network analyst and a software developer. And he gets his kicks from trying to decompose protocols in a systematic way that software can handle it for you. Just like, for some examples, like Wireshark can extract things out of HTTP sessions. He does a lot of that analysis for you. Wireshark really gives you that microscopic view, and he's actually taking a little bit of a step back and giving you a little bit bigger holistic view, in my opinion, of what's going on in the network. Now, his tool isn't specific to performance. It is more security-based because he is a security analyst. He deals with that all day, so he writes tools that are useful for him. This is absolutely free. It's like less than 100 megs executable. It's a portable executable. You don't have to install anything. You can take it on any Windows machine, carry it on a flash drive. He also has a pro version, which has some really awesome features. I think it's about $1,000 for that. And he's a company of one, essentially. You are helping him develop this software for free. So definitely give it a shout if it's something that you like. All right, so I'm going to open it up, and all of these demos, I'm really just going to process, I think, the same network capture. So what you're going to be able to evaluate on here is, at least on my machine, what is the load time for looking at these packet captures, these trace files. Network Miner, as far as I know, is only a Windows-based product, but you can run it in Linux with Wine. It runs really great. It has a pretty simple, let me just minimize that. It has a pretty simple interface, and all I'm going to do is just load a capture file and see what it does to it. Desktop PCAPs, and I'll just grab this one. Open. So if you guys are playing around with this, you want to explore this tool, I want to tell you that the free version, this is how, he tries to make some money, for himself. The free version will only process PCAP files, not PCAP-NG. So if you want to be able to process PCAP-NG files, you need to convert them to PCAP. Some, obviously if you're capturing from multiple interfaces, that won't work. You'll need to normalize your interfaces first, then convert, or pay for the pro version. It breaks it down really quick. So this packet capture that I'm loading is about 100 megs. I should have showed you the file first. I'll do that next. It's about 100 megs. It's all web traffic. What I did was I needed to start generating traffic for this simulation event, and I just stood up a virtual machine and wrote a Python script to go through like the Alexa Top 1000 and just browse to every website, scrape for links, and go a random number of links deep into each website before it goes to the next one. So this is all just pure web traffic. What comes with that is DNS traffic, so before every web request is a DNS request, as well as some broadcast and multicast traffic that was on that network segment. So it was, I'm trying to compile that other thing, and I'm wondering if I should stop it. All right, so it doesn't slow down the rest of the tools. I'll just kill that one, and we'll talk about it when the time comes. So as you can see here, I'm sorry the text is so small. I can't really zoom in with this software. So I'll just kind of describe what I have on the screen. Hopefully the folks in Zoom can see it more clearly. There's a number of tabs up here. These are just quick access things that you want to see. First one is hosts. So it parsed that entire PCAP file and identified 1,540 hosts. Those are unique addresses and some of the fingerprinting that goes with it. Some of the fingerprinting is displayed here in some of the icons. This is a Windows icon. Again, I know it's hard to see right there, but it's a Windows icon. So it's sort of fingerprinting the operating system that it thinks generated that traffic, which is super cool. Wireshark doesn't do that by itself, right? So this is a complementary feature. The rest of these unidentifiable hosts that it can't determine, it just puts the computer icon. What it's doing here is also on that IP address, which is in this column, it's also stacking to the right of that every domain name or subdomain or CNAME that resolves to that IP address. So it's stacking that all for you right in one row. And you're able to expand any of these to be able to see more information on that. And this is just quick access information. So these are individual hosts. This isn't network sessions. They're just individual hosts that you can tie all these artifacts back together. The MAC address, if it knows what it is. The NIC vendor, again, it's using the OUI file set to resolve that. How many sent and received packets and bytes have gone either to or from that host? Super cool. How many incoming individual sessions or outgoing sessions have been seen originating from that host? So a lot of quick reference information. You guys have all been here for 2 days or more already. How many people are doing the CTF, have participated in the CTF so far? Okay, a few. Anytime I've done a CTF, whether it's here or anything else, I open it in Wireshark and I open it in Network Miner. Network Miner is going to give me a ton of information immediately. Other information that I might have to derive out of analysis from Wireshark. Now, if I need to look at the bits of a PCAP, of a trace file, Wireshark is your go-to tool. If you need to determine things like what might be the operating system for something, it's right there. Another quick thing, I'm just going to kind of give you guys a quick demo of each tool, just a few minutes, and then we'll go through the next one. Across the top are a series of tabs. These tabs are just ways to quickly access some of the features that it is. Here's every file that it has been able to extract. Now, because the traffic generator, so to speak, that I used to generate this was using HTTPS, a lot of these files are just certificates. Otherwise, there are going to be some things in clear text, maybe a few images, things like that. But it's automatically going to dump that out, as opposed to Wireshark, where you have to go and export objects down to what might be in the PCAP. So it's doing that already. It's also linking those files to the host that they came from. Right? I think it's super cool, super valuable, really quick and easy to determine a lot of this information. Destination host is a Linux box, and it's going down and down and down a huge list of 1,200 items. Images, it isn't giving me any images. That's okay. Credentials here, actually, these shouldn't be any credentials. There shouldn't have been anything that was passed in the clear for any reason, but it might be pulling some credentials out of some of the web traffic that it's seen. where there's been a username and a password field, or if if it was passed as part of the URL string. Sometimes it might misinterpret something that's a U equals and a P equals and assume that that's a username or a password, or a cookie or anything like that. Sessions, so this is where you start to get into a tool that is session aware. This is one of the biggest things that I struggle with Wireshark. Wireshark is amazing at looking at the packets, but sometimes I just need to know the sessions. Tell me who is talking to whom. I don't really care about how many packets were involved at the moment. I just need to know who was talking to whom. And that's exactly what this is starting to break down. It's giving you some of that information on those sessions. Who was the client and who was the server. Now, what if I gave this a trace file or a packet capture that was midstream, that had a TCP session that didn't have the initial SYN, or didn't have the initial three-way handshake, I would say? Would you be able to derive who was the client and who was the server in Wireshark? Well, Wireshark doesn't give you any indication of who's the client and server, although I think they're starting to do that now. But a lot of the tools that we're going to show, as well as Network Miner, tries to do some heuristics to figure that out. Right? It knows that answers are coming from a DNS server and not the client. It knows that the DNS requests are coming from the client. So typically in a TCP session, you're making a request and getting data. Right? So the data coming to you is generally more. We operate in a client-server fashion. DNS requests, again, just like Wireshark's going to parse it out. It does the same thing here and puts it all on one line. So if there are a number of C names that ultimately resolve to an IP address, it's going to put that all together for you in one line. So super cool, super easy. Parameters. I've never used this. I would need Eric to tell me what is the most efficient way to use this and what is it telling me. I don't know. Keywords and anomalies, I think they kind of speak for themselves. There is here, this allows you to search. So this is equivalent to Wireshark's magnifying glass, the search function, where you can search for a string or a byte string or a string of hex, I should say. This is very much the same thing, and then it will parse out which of your packet captures that was in and which sessions that was in. So this can also load up many capture files at a time and do this analysis across all of them. On the right side of the screen there's a case panel where you can load up multiple capture files at a time. So that's super cool, super handy, allows you to analyze all that at once. It parsed it all very quickly, in my opinion, and derived all of that data. All that data was in the PCAPs. Wireshark, you can get it from Wireshark, but it's just parsing it out for you. So I think that's super cool. How many people in here have used Network Miner before? Yeah, okay, just a couple. Again, this is a more security-focused product, not so much performance, but it's one of my go-tos. I'm going to open your trace file first in Wireshark, if it's small enough, and next in Network Miner, just to see what it pulls out by itself. I'm not going to put any display filters or anything like that. I'm not hunting. I just want to see what it pulls out by itself. So that's my quick demo on Network Miner. I'm going to go back here. Okay, the next one I have is NF dump. How many people have used NF dump before, or any of the NF series tools? No, okay. NF is just an indicator for Netflow. So it's a series of Netflow tools to collect Netflow, to derive Netflow from a PCAP, which is what I'm going to show you, to display some of that data in a graphical format. So in this case, I'm just going to show you via the command line, because again, Wireshark is great for looking at the packets. It does not do a really good job of telling me who is talking to whom. Netflow is the go-to tool for that data. Netflow doesn't have a client-server context. It assumes everything is unidirectional, so it's up to you to derive that. But there are some really cool, I'm going to say filters, maybe not filters, expressions. Some really cool expressions you can put on the command line to derive some really neat information for your environments. If you guys are collecting Netflow, first of all, you should all be collecting Netflow. Whether it's for security or for performance, you should be collecting Netflow. Netflow is one of those things that as a network engineer, and when you start to get into the analyst world, I call it living off the land. All these devices in your network are seeing the network packets. Most of them can generate Netflow. Why aren't you collecting it? It's so simple. There's a lot of fancy collectors out here, but here's a super simple command line collector, and this one I'm going to read a PCAP in, if all goes well. All right, so I have a PCAP here. It's the same one. It's called web traffic. It's the same one. So I kind of want to show you this as well as how fast it's going to parse all this. Because it only has to derive Netflow information, it doesn't care about the bytes in the payload. It just cares about what the lengths of those payloads are. And once it has this information, the files that it generates are much more compressed than the original PCAP itself. So if for security reasons you need to have a log that goes back 10 years of which hosts are talking to which hosts, you're going to have a hard time saving that as a full PCAP to be able to analyze 10 years from now. But it's going to be super simple to save the Netflow records of that because they're either text or already compressed binary data. Text data compresses really, really great. All right, so this one is the same web traffic, and I'm going to process this PCAP. So I've already installed this, I've compiled it, and I've turned on the capability to read PCAPs. So I have this PCAP one. I'm going to do npcapd. Actually, you know what? I saved myself the trouble by already doing the commands here. All right, so this is a nfpcapd. This is the PCAP daemon, but you can also, with this daemon, start it as a Linux daemon and actually send Netflow directly to it. It will start listening on a port. I'm giving it the TAC R down there at the bottom to read in the traffic PCAP, and then I'm telling it to output all the data with the TAC L, all the data that's going to generate into this directory, which is output. And I'm going to go. That's done. It just took a second. All right, so if we go into our output folder, let's take a look what's in there. We have a ton of files. These files are pretty small. That whole PCAP was 100 megs. Together, this folder here, I think, is really small. What is that? I'm trying to think. Thank you. 1.9 megs. So super, super compressed. So you can keep this for 10 years. You can stuff a whole server with 10 years worth of Netflow. Okay, so what's in these files, they're not really readable. They are a compressed binary format that the NF tools use themselves. It's not proprietary, it's open. You can, if you can read code, I guess you can do it. I can't read code, I don't know what it is. So we have to use another one of their utilities to parse it. And I'm going to show you that on this other command that I pre-staged for myself. This one is super cool. This is available on GitHub. I'm going to share all the links for all of these tools. I'm going to publish both PDFs for my first talk and second talk afterwards. All right, I'll paste that in. So I'll just go through what this is. It's down here at the bottom. I'm sorry if you guys can't read it, but it's NF dump, so the Netflow dump. I'm reading in, it should be this first file. I just want to take a look at that first file. Just to keep it short. N15 is showing me give me the top 15 records, number 15. Give me the top 15 records. The tag A, the capital A, is aggregate. So out of all the records, I want you to aggregate into the IPv4 source IP and IPv4 destination IP, and then just show me those subnets. And then sort by, can I move this? Yes, sort by records over bytes. So what this is going to show me is which /24 subnets have exchanged the most bytes, or the most records. So this is not necessarily hosts, because that's not what I'm aggregating by, but it is going to be the /24s. So I think this is super cool, because this is like a who's talking to whom, which is exactly the thing I want to find out all the time. But instead, I'm aggregating it into the subnets, because if you're in an IPv4 world, most people Separate VLANs on the /24 mark because it's a simple way to manage small groups of hosts. So I want to know which of these is exchanging the most data or having the most flow records with the other one. So this is pretty cool. Again, has no context of client and server in a conversation. Instead, it's just source and destination IP. So you will see, let me see, this one here. This is my source subnet, so my client is here in the 10 network, some private space, that VM that I used, and this is, I know it was making DNS requests out to 1.0.0.1. But also the responses are counted individually because it considers both flows unicast. So when you want to aggregate that together, you might need to pair up both of those records you see there. A lot of commercial tools will sort of do this for you if you want, and we can do it here as well, but I don't have the expression ready for it. So again, this is just Netflow. There's a million ways to look and process Netflow. Personally, for my small company, I use Elastaflow. Elastaflow was made by Rob Cowart, now kind of a friend of mine, and he started it on Elastic Stack. It's just an Elk stack, and he put some sort of Netflow-centric data, graphs and stuff on top of it, and it's really cool. So now he's built a Netflow collector. And so I'm just using Elastic Stack. It's super easy. I mean, I have 3 sites at my small company. Netflow's free. You know, I don't have to pay anybody for it. The device is already generated. Just collect that stuff. Super easy. So that's Netflow. So how many of you out there are collecting Netflow? Only a couple. Okay, definitely. All right, excuse me. Okay, so that's nfdump. To grab that, that's on GitHub. His name is Peter Haig, and let's see if I have it up here. No, Peter. Let me see. GitHub. This is Peter Haig. This is his GitHub, so this is where he has all of the tools, the Netflow tools for doing Netflow analysis. Super cool, free and open source, and I think he picked up this project from someone else who started it, and I think he's continuing the development for it. Don't quote me on that, but because I don't know how far back the history goes, but I think that was the case. And you can find a lot of presentations from him that really teach you smart and efficient ways to use this tool and to derive information from Netflow online. I've used a bunch myself. Okay, so jumping back over to our list, that was the Netflow one. Zeke, the third tool there in the third bullet, I'm going to have to talk through because that was the tool that I was compiling, and it was just taking a while. I'm compiling it on this machine in the WSL2, the Windows subsystem Linux, and it is just stone slow. And I can't speed it up. As well as I'm trying to process packets and give demonstrations. So Zeke, I don't know if my description can do it just, but if I had it spun up and I could show you how some of the scripts work, it is really, really cool. Zeke can listen on an interface or read from a PCAP. Either way, it wants to look at network data, but it is an event-driven framework. And what that means is, if any of you have heard of or messed with IPS or IDS, typically these kind of products are packet-centric. They have very little idea of sessions. Zeke specifically is focused on sessions and events in those sessions. So it's very context-aware about what's going on in each session. And it does that by tons and tons of people committing tons of event languages and plugins and all kinds of stuff to process different events. So one of them, actually, I hope I can show it. I'm going to compile it tonight. I'm going to have to. And one of the events is something that Wireshark couldn't do for me. And in fact, this is an example. I'm looking at Andre because I know Andre and I both took the same SANS course earlier this year or last year. And this was an example in the SANS course that they wanted us to do, and you just couldn't get it from Wireshark. And in fact, I have an open issue on Wireshark's GitLab for this feature that they haven't Done yet? It's show me every session, in this case it would be like an HTTP session, that had, let me see if I can phrase this correctly. Show me every session that has been connected, or show me every destination that has a connection that we have seen a DNS request for. So what that means is if I'm asking for Yahoo, I'm doing a DNS request for Yahoo. I send out my DNS query, and I get back the DNS answer containing IP addresses, in this case IPv4. Then I expect to see some client connecting to one of those IP addresses to connect to Yahoo. Almost every connection in your network in today's world is going to have a DNS request first, right? And normally that's going to circulate around a couple of CNAMEs before it resolves to your answer. So what if we were to take a look at a PCAP and say, show me everything, every connection that doesn't, every IP address that has a connection that wasn't in an answer to a DNS request. That's something that Wireshark can't do at the moment because it can't tie the list of IP addresses in the DNS answer to then become destination IP addresses to follow-on requests, whether they're HTTP or whatever. But Zeke can do that. You have to write a little Zeke script. That was the exercise for our class. You have to write a Zeke script to do that, but it's pretty easy. It's less than 100 lines. I mean, it's far less than 100 lines, as a matter of fact. But it was pretty simple to do. And it's super cool, and it does so because it's session aware. It can maintain that list of DNS answers and then look for those follow-up replies. So why would we want to do that? Well, not all malware communicates directly to IP, but some software, and more popularly, some malware communicates to hard-coded IP addresses. They actually don't make a DNS request first. They're just going to connect directly out to an IP address that whoever wrote the malware, it has a server waiting, whether it's a C2 server or anything else. Just one quick way to do a hunt like that can't be done in Wireshark. So Zeke is super cool. I'm oversimplifying the utility and value in it, but there is a little bit of a learning curve. So when it reads in packets, PCAP or traffic off the NIC, it actually dumps all of the analysis, all of the data, the metadata that it generates into plain flat text files. Plain text files are really hard for us packet analyst people to look at, so normally you hoover all those up and put them into a database that you can then search, whether it's Elastic or Splunk or anything else. Almost every database out there has a way to bring in Zeke data. I highly recommend it. Again, these tools that I'm showing you right here, every CTF I've ever done, I just run the same PCAP through each of them and just show me what these tools extract by themselves. Just give me the context of what's going on.
There's a question in Zoom.
Go ahead.
Is there an NF dump for Windows?
Is there an NF dump for Windows? The question was, is there an NF dump from Windows from Zoom? I'm not sure. I would go to the GitHub, and again, I will share those links out with the PDF afterwards. I don't know. I know the one that I just showed you, the command, I just ran a couple of simple commands. I had to compile it like an hour ago. So I don't know if they have releases.
One more question.
Go ahead.
How does NF dump determine time zone?
You know, actually, I think you would have to set it. And you don't set a time zone, but when you do your analysis, the question was, how does NF dump determine time zone? I think you set that when you run the commands for doing the analysis. Okay. All right, I'll move on to the next one. The next one is Sorikata. Sorikata is an IDS or a network IDS or IPS. It is a free open source software. Again, you can grab it straight from probably GitHub, but they have releases almost for every major OS. And it is a go-to tool. So I think there's two super popular IDSs, Snort and Sorikata. So how many people, show of hands, have used either of those? Okay, very cool. So Sorikata is a network IDS. A network IDS typically gets its packets, it hoovers them right off the network via a tap. You know, we have some tap vendors out there. And so typically it will take a look at all of the network traffic. And what it does is it actually runs each packet, just like how what Wireshark sees, runs each packet against a rule set or a set of signatures. Those signatures are typically looking for different bits or bytes or strings, either in the network layer headers, the IP, the Ethernet, or the TCP UDP layer, or actually in the application layer, sort of in the data payload of those layer 4 protocols. Almost always when new malware hits or network worms or anything, there's tons of signatures created for them. They're free and open source. You can grab most of them pretty good. Pretty quickly. A company that's really good for that is Emerging Threat. Emerging Threat is a rules vendor. They have an entire open set of rules that anyone can grab anytime. I think there's like 100,000 rules in their open set and tons more in their pro rule set, which is what you get when you sign a contract with them to supply you their rules. So how would I use this tool? I'm a network analyst. Why do I care if I'm not into security? Because it enables you to write a simple rule. Their rules are text-based. They're super easy to read. They're like an ACL almost. Source talking to destination over TCP, look at the offset byte 2 for the next 2 bytes should be AA. Just something in hex, something simple. Or it could look for a string value. One of the things that I derive a lot of value from it on my network is DNS requests. As long as your DNS requests are still in the clear, right, you can match a lot of information off that, generate alerts, but they're not actually alerts. The traffic's not bad. I just want a clean way to be able to keep track of who's making the DNS requests on my network and for which domains. I do a lot on my home network, and so I'm watching the wire all the time. I hope all of you are as well. Some people. So anyhow, so I'm just going to run this. I'm going to run Sorikata here. So again, I just downloaded it earlier this afternoon. I was trying to get the latest tools on the box before coming down here for the talk. So I have it installed, and this is on my Linux subsystem here on my Windows machine. And I have it installed. I'm going to read in my web traffic file. I'm in the wrong directory. So I just fire it up, Sorikata, read in my web traffic file, and you can feed it an interface, and it will spin up as a daemon and constantly listen on that interface, just listening for all traffic that you can send it, which is why you typically connect it to a tap. Or you can read in packet capture files for doing offline or after-the-fact analysis. So this is just giving me a couple of warnings that some values in my config file will change on the next release, so it's telling me to go ahead and change that now, be prepared for that. But it just processed all the packets that were in that web traffic PCAP. And that was 100 megs. It's not a lot, I get it. But it was super quick, and it's running thousands and thousands and thousands of signatures against every packet and every payload. So it's super fast. It is a very fast engine. And it can support multiple threads. So if you actually want to put this on a big fat network, you can run multiple instances of Sorikata across the cores of your processor and actually fan out how it hoovers up all of the packets and really keep up with like a 10 gig link, which is super, super cool. What it generates generally 2 files. One of those files is called fast log. It is a flat text file, and it tells you source IP address to destination IP address and the signature that fired. Now those signatures, again, don't have to be looking for malware or anything bad in the traffic. It could just be simple things like someone made a DNS request to my domain, showipinterfacebrief.com. That's the point is while this was originally built as a security tool, if you think, oh, it's just matching bytes in a packet, you can write signatures for anything. I can write signatures for TCP headers and match those as well. There are some rule sets out there that are more geared towards network operations and performance, so if you wanted to leverage the tool for that, you definitely could. I'm going to show you those 2 flat files. I do believe Let me see, fast log. I do believe fast log is actually 0 bytes, if I remember, because that web traffic. Let me see, LSTech, LAH. Let me see, where am I? It's a 0 bytes file because didn't have any signatures that actually fired. That traffic that I had was benign. It was making very generic DNS requests and browsing to a website via HTTP. So the signatures that I have loaded in here are actually looking for malware, looking for C2 traffic, looking for known bad IP addresses, connections to or from known bad IP addresses. But the other file that it generates is called the eve.json file. Sometimes it's named alert.json, and this is a super long and compact JSON file that contains all of the flows from that PCAP. I'm just going to Control C for that. All of the flows, so it's getting, basically, it's kind of deriving what would be Netflow. I understand this is JSON and it's hard to read. It's great for machines, but it's hard for people to read. You don't really have to read it. The point is that it dumps JSON out so that another machine can read this file. It's not for human consumption. It's so you can dump this into Elastic or Splunk or any other sort of database and build virtualization graphs and things around either the security of your network using the alerts or some of the performance or the traffic that you have here. Again, just one of the rows that I highlighted there, just simply, this is basically a flow record. It's called the flow ID. It's giving me how many packets were in there, the event type, this was TLS, the source IP, the source port, destination IP, destination port, protocol, the SNI. So it's giving me the server name indicator for that session. I didn't even ask for that. So now I can just basically ask this file, just show me all the SNIs. And it's super fast and super simple. Here's one from mastodon.social. That's interesting. Okay, so I want to move on from Sorikata because the beauty of Sorikata is its speed and efficiency, but it's really not pretty just to look at files. The whole idea is you take that data and you feed it into a database or a graphing engine. Now, the next tool I am pretty excited about because this is called Brim. Brim, if you guys remember, I think last year's SharkFest, or the SharkFest before, it was Steve McCann. He gave the keynote talk. He is one of the creators of Brim and Brim Data, the company Brim Data. And specifically what he's done with this product and this company is he's created sort of a new data lake format, a way to store and aggregate all of this network data that we're gathering in a most efficient way, and something that I think he calls it like a type-aware database. So it's very aware of the data types that are in there, but there's something about it as well. I'm not a database guy. I'm not a developer. I don't know that stuff. I just know the zeros and ones. So one of the beautiful things about this, and sadly, I don't know if they're going to keep making this piece of software, but they are going to keep developing their data lake syntax and file formats. The beautiful thing about this is a graphical way to look at Zeke and Sorikata and any of the PCAPs that you have and allow you to build queries on them. So I think I'm just going to show some sort of rudimentary stuff and what's built in, but it's super cool. So again, I'm just going to grab that same file, which I have on the desktop somewhere, PCAPs. I'm just going to grab that single file, just one. I think this is the right one. It's about 100 megs. It's about 100 megs, so let's open it, and I want to show you some of the cool things that it has baked in. And you know what, maybe I'll start closing some of this other stuff. Don't fail me now. So what it's doing is it's parsing the PCAP, and it's generating all that metadata using those two previous tools. That's why I love this one, because this is a combination of the two previous tools. It's generating all that metadata. It's putting it in its sort of proprietary, I think it's called Z data, is the data format that they built to hold network data. And then it makes that easily queryable and easily parsable. So this is what it looks like after it parses that PCAP. It is it might look a little messy. I get that. It's not a pretty graph, you know, like we would anticipate something having. But there's a lot of rich data here. I want to go through sort of what this is and explain it a little bit, and then maybe you guys would be able to use this in your future investigations, whether it's performance or security or just awareness. As I mentioned, this is the two previous tools shown together. Zeke breaks out when Zeke reads in your PCAP or reads packets off the wire. It's analyzing all that. It's an event-driven framework, and then the output are just flat text files, and each of those text files has a different colored tile here. So there's a files text file, and there's an X509, there's an SSL, there's a con text file, which is just a connection tracker. Very much the con log looks and contains very much the same data as Netflow. Source, destination, timing, bytes this way, bytes that way, different flags that have been seen. You can almost build a Netflow system off of this file that Zeke generates by itself. DNS requests, really rich context about DNS requests. Again, any files that were dumped, and because this was a web thing, I don't think we're going to see many more, but there are many other types. It is also processing that same PCAP against Sorikata and the open set of rules. So if there were security alerts, if there were, you know, I don't know, network malware or communication to C2 servers, it would actually highlight that as a Sorikata alert, and it allows you to pivot between the Zeke data and the Sorikata data. So instead of having like your web dashboard at your NOC or your SOC where you have all these tools, different web interfaces up in front of you, this is just kind of a bunch of things combined into one. And if I want to look at this, so I'm just going to pick one of these at random just to show you about it. I'm double-clicking here. It's going to open a detail window that allows me to take a look at that. This came from a con log. And what this is telling me here, at least this pane right here, is that inside this network connection, I'm also seeing some SSL traffic. It's also giving me, I think, what do you call this, a bounce diagram? It's giving me a bounce diagram. I realize it's sort of white on light-colored stuff, so and I don't think I can zoom in on this guy, but this is a bounce diagram. So this shows you the originator and the responder. That's Zeke's language for client and server. And it's showing you the SYN, ACK, as well as some general information about the bytes, the packets, and timing like that. And this here on the left side are all of the fields that Zeke is generating just on this one connection. So this is super, super rich. It's normally, let me see, oh, I don't have my MaxMind database loaded. I was going to say, it's doing the geolocation and everything for us. What I really, really like about this, if I can do it, oh my gosh, I don't have it loaded, I don't think. Oh, yes, I do, okay. Oh, I thought I was going for an epic fail. I was saved. This software allows you to take any connection that Zeke has seen, that Sorikata has seen, that Brim has processed, and just click on the shark fin in the upper left, and actually, because I clicked it twice, and actually pivot to Wireshark with just that session, just those packets. So I think that is super, super cool, right? This is equivalent to like your follow stream, you know, if you picked out an individual session. And this allows me to just sort of navigate through it using Wireshark, just a way to pivot. Again, I opened this talk by saying Wireshark gets you down to the bits, and sometimes that's too close to really see what's going on. So you have to back up. That's one of the things Netflow gives you. It gives you some 10,000-foot view awareness. Zeke is doing much of the same, but I love this tool here, Brim, because it allows you to pivot back down to that microscopic view that Wireshark gives us. That's what we all love about Wireshark, right? The bits can't hide anywhere. So I love, love, love this. I don't think there's going to be anything interesting. I wish I had like a nice threat traffic or something to show you some interesting things. But I don't. This is basic web traffic. I'm going to go over a couple of these simple ones because I think there's a lot of value in this right here. This is your activity overview. These are query. I should have stepped back and said, at the top of this tool is a query bar where you can actually write different queries. And on the left side, these are pre-built queries that Brim just gives you to show you examples of what's going on. One of them is the activity overview. One of them is unique DNS queries, Windows networking activity, HTTP requests. This one's just unique network connections. So each of these are great questions that I want to be able to ask Wireshark, but Wireshark doesn't give me that context awareness, whereas these tools are going to. So I'm going to click on Activity Overview. This is breaking down all of those connection types that Zeke is showing you: connections, DNS, SSL files, stats, weird. Zeke gives you a weird file, and a weird file, it puts an entry in the weird file for any connection that it has to analyze, and it's just like, I don't know what this is. I don't know what this is, but let's just log the connection and put it in the weird file. DHCP stuff, and then error. Oh, this one is something is missing. Oh, that's the Sorikata alerts, I do believe. And notice, I don't know what this one is. We can double click it and open it. This is a single notice event. We can right-click anything, and I can sort or pivot to these different groupings. DNS queries, there's a ton of intelligence in DNS for your network, whether it's performance or security. So this gives you that was just super quick to be able to derive that information. I don't think providing a count is something that Wireshark can do for us. I think if we were to search for DNS queries, it doesn't aggregate them like that. These pre-built search queries are building the query for you up at the top. So any query you ever make or your teams make or anything that you want to save, you can just click the star and it'll go down into your saved queries folder. Windows networking activity, I guess I'm not going to have much of that because I was just making web requests. HTTP requests maybe. So here's a demonstration of us getting a bunch of port 80 stuff from port 80, and it's breaking out those fields for us. And again, I'm just going to grab Illinois. What is that? Something for the affairs of Illinois EDU. I'll open that guy up. And I wanted to, I think I double-clicked too many times. I need to go back to the connection ID for that guy is what I was trying to find. Which is called, Andre, do you remember the connection ID? Yeah, is it UID? All right, let me try that guy. So I was just kind of like clicking quickly through that, and I'm sorry for not doing it slowly. I was just trying to fumble my way through it. But what I wanted to show you was that we were looking at HTTP metadata, and by opening that up here and taking a look at the details, I had to include the UID, which is just like a hash value. I can just generalize it as that. You can right-click and pivot on that and say new search with this value. And what it will do is go back through those logs and show me everything that has that value in it. So now I can take that con log, open it up, and again, I already showed you guys this, but here I can go ahead and pivot over to Wireshark again. All roads end at Wireshark. Ultimately, when you want to look at the bits or bytes of something, all roads end at Wireshark. There is no better tool. That is the tool. So just showing you that as another demonstration. Any PCAP I get, if I don't know what's in it, I'm going to throw these tools at it, and I'm going to gain a ton of intelligence about what's in it, more so than I would, because everyone's been saying, like, you know, do you filter or do you scroll? I'm a scroller in Wireshark, so I will derive a ton of information just from throwing the PCAP in these tools very quickly, more so than I would just rocking that scroll bar up and down. But that's me. So again, I just pivoted to Wireshark, and it opened up just the packets that were in that session. So I don't have to open that entire PCAP and scroll down. There's no display filter here. It's just that session. So I really love that for being able to isolate traffic. Go ahead. I see a question from Zoom.
Yes, someone's wondering if there's a more CLI-based workflow for Brim.
Yes, absolutely there is. The question was, is there a more CLI-based workflow for Brim? There absolutely is. Steve McCann talked about that in last year's SharkFest. You guys got to correct me if I'm wrong, keep me honest here. And I think he talked about and gave some slide demonstrations on the command line. If you go to Brim's GitHub, this is free open source. All of the stuff they make is free open source. I think the company's now called Brim Data. It might be Brim Security now, one or the other. And there is a command line version of this. So sort of like there's the JQ tool for looking at JSON data. They make a ZQ tool for their data format, which is called Z. So, you know, like we need another data format, but yeah. But theirs is far superior. Okay, so now those are the 5 tools I wanted to show you guys. Now I wanted to show you guys at least 5 online sites that are free, anyone can access all the time, that I'll turn to if I need them. Sometimes I turn to them all the time. Sometimes they're there in case I'm in a situation where I can't install tools. I don't know about you guys, but in a lot of the different networks that I work on, I can't install anything. You want to install something, you have to go to the administrator. They have to install it and push it out to your machine, or they got to come over and do it locally. But before they can do that, whatever tool you want has to be approved and typically scanned by the security team. So a lot of times I'm looking for ways that I can just look for free online tools that will help me derive data. And some of those you can actually run locally. So you don't have to worry about giving data out to unknown web servers. Okay, so I'm going to do that with Packet Total. Oh man, I love Packet Total. Okay, so Packet Total is an online packet analysis suite. So all you pretty much do is you just click and drag a PCAP, and it's going to analyze that and give you a ton of output. What it's going to do is take your PCAP and essentially run it through Zeke and Sorikata. I don't know if you guys can tell, but there's sort of a pattern here, right? I demoed 2 tools called Zeke and Sorikata. Then there's the Brim, which is Zeke and Sorikata baked in. Then there's Packet Total, which is Zeke and Sorikata baked in. These are the go-to tools. They're almost never, I'm not going to say they're never exclusive, but very often you run them together, because each operate on the network differently, they derive different information, and you want both, and they're free, right? Give back. Okay, so let's grab a file. I'm gonna give it the same file. Actually, oh, it's a 50 meg limit. Oh, I should have known. Okay, all right, let's find a different one. As if I don't have enough stuff going on. Okay, pre-stage, need to edit. Okay, this is one of my pre-stage PCAPs that I did for the CTF challenge that I built. So it shouldn't find anything. Let's see what happens. That was a half meg. So this is going to be kind of boring, right? Because there's not a lot of stuff in there. Uh-oh. So yeah, there's a server issue. There's something definitely going on there. Look, what are they doing? All right, let me see if I didn't expect this website to ever not work. Or maybe I should have tested it. I was just taking its availability for granted. Let's just see if we can showcase some of the packets or some of the sessions that have already been uploaded. Okay, so this is one file. This is a file called HE000 PCAP. It is 10 megs. You can download these to your local hard drive. And along the top are the tabs, and a lot of the data that's in these tabs is derived from Zeke and Sorikata. Let's see, if I open this guy up, it should give me some information in here. My connections, that should be coming from Zeke. But I may have to just skip this guy. Yeah, maybe something's going on there. And I did see that that website is now, or that company is now part of Dynamite Analytics family. Maybe something's going on. It's weird. Anyhow, I won't go through the upload again. I'll just see if we can leverage something that's already there. I'm just clicking one of the PCAPs that was already uploaded by somebody else. Again, if I click over to connections, that's kind of where I left off with my own. This is very much the same sort of metadata and the same information that is generated from Zeke. This is really, really cool stuff. There's a lot of things that are sort of baked in here that you can leverage. You can see I can kind of hover over some of these icons that are added to the IP addresses. This will allow me to either search for these IPs on packet total or geolocate them on a map. Clicking through just to show some of the things that it has, and I want to see this one. This is something that I don't know, you can't get from many other places, but similar packet captures. I don't know what it's going to generate here. I've never seen this PCAP before. But typically what it'll do is if a PCAP has the same hash value, I don't know, it looks like it's crashing for me right now. If a PCAP has the same hash value or contains a lot of the same IP addresses, you know, maybe it's a malware sample or something that you're uploading and you wanted to see how broad this is, how big of a problem this is. Very much this operates the same like VirusTotal. You guys heard of VirusTotal? VirusTotal's the online malware and virus sandbox that you can upload malware samples and they will check the hashes and see if it's in any vendor's databases already. And then on the pro version of that, it allows people who have VirusTotal Pro subscriptions to download those malware samples that were uploaded and reverse engineer them and stuff. This does a lot of the same, right? It's supposed to be able to look at PCAPs that are similar, but it's crashing for me still on Chrome, so maybe it's just a me thing. That's okay. I'm going to move on from that, though, just to keep us moving along. But I can't remember what my next one is. Oh, A packets. Okay, let's see if I can get this one right. A packets, I'll just use this one. Are you in there? All right, A packets. Let me take the FAQ away. Okay, this one is an online PCAP analyzer. Again, maybe you've showed up to a place to do analysis to help someone out and you forgot your charger at home. And all they have laying around is a Chromebook. You know, where would you turn? There's tons of really cool tools out there that people have built, and so I really like these. So let me see if I can do this. I don't know if there's a size cap on this one.
Correct.
Yeah, absolutely. The question was, like VirusTotal, you need to have the same security concerns on packet total about uploading sensitive data. Absolutely. You don't own packet total, and you don't own VirusTotal. So whatever you submit, everyone else, you should be in the mindset that whatever I submit, everyone else can see. So if that's sensitive data, if that's sensitive PCAPs from inside your network, you need to be aware of that. I don't know, and with the way the website is acting up, and it says that now it's part of Dynamite Analytics, I don't know if maybe they got bought and are moving, so I don't know. I don't know if there is. All right, so this one, let me see my report, view report. It takes just a minute to churn on those packets, but I like how this is sort of broken out. This is a very different feel. Again, this is something you could do from a Chromebook, you know, packet analysis from a Chromebook. Here's some tiles that sort of break down some of that network traffic for you. I told you that one was from my CTF, so I know it is all HTTP traffic, so that's the only tile that's lit up here. Let's go ahead and jump over to that. You can see that there's 454 GET requests with 200 OKs. Okay, I remember what this was. This was part of my CTF. And then this is giving us a breakdown of those sessions. So, did anyone do the CTF yet? This one? Yeah, Andre did. I know he did. Anyhow, this was from me pre-staging some of the code for that. Yeah, so it's just me bouncing back and forth between two servers. So not really interesting, but again, a super useful tool and a very different way to present that data. This is not your typical Wireshark view. I'm a graph guy. I like graphs, so give me all the graphs. I want to show you a different one of these that operates very much the same. It is Packetor, and then I'll finish up with the last two tools here. This one is Packetor right there. And so you do the same thing. You can paste in packet payloads, and it's going to decode that packet for you. This gives you more of the traditional Wireshark feel. Like when you open up a PCAP in Wireshark, you have your packet list, you have your packet details, and you have your byte details. This is much more that packet details style view. This right here is actually where you paste in your files. In this case, they just have some raw hex here, so I'm just going to hit decode packet because it's pre-populated with its own data as an example. And you see right below there, it shows very much the same data that you would see in the packet details window. So you can expand and take a look at any of these. I don't have to show you a demonstration. You guys know exactly what to do with this stuff. But again, just another way to be able to work with your PCAPs. And this would definitely be useful, again, if we had a Chromebook situation, a Chromebook scenario. And I'm going to try and do an upload. I think I can do an upload here. Packet on says strings, hexadecimals, or digits as input. Okay. Spaces, new lines are ignored. Just place your packet dump in the box and save and hit. Okay, so it definitely wants hex data, and I don't have any raw hex data at the moment. But again, another super useful tool that's just pretty simple. Again, be concerned. Please have the same concerns as you would any public tool, any data that you put on the tool. Please do so with the mindset that everyone can read your data. So be aware of the sensitivity. I should have mentioned that at the beginning. Okay, and my last two are TLS and Quick Illustrated. So this is, if we go over to XArgs, I think that's how you pronounce it, XArgs. Maybe some of you coders can tell me. How many of you have been here before and seen the TLS Illustrated website? This is the most useful tool, even more so than Chris Greer, okay? Even more so than Chris Greer on learning TLS. I'm going to go through this, but what this does is this breaks down TLS 1.2, TLS 1.3, Quick. Oh, and it looks like he's got another protocol up there that I've never seen. X25519, I don't know what that is. But what this does is for every exchange of data in the TLS handshake that happens after your TCP three-way handshake, he breaks that down, and this is a very interactive website. So coming from the client, coming from the server, back and forth. So here's your client key generation, and this has to happen before the client hello. So that's why it has this plus and minus as opposed to the arrows. So when you open this up, it actually explains how these things are generated. This is not something you can see in a packet, right? It's not part of the packet payload, but this is needed to be able to start having that TLS handshake. So this is super cool because it's giving you some of that data, explaining to you how that data is derived, and showing you how it's used. Then the next thing, just as an example, is the client hello. Most of us know that that's going to be your fourth packet, right? I've done a three-way handshake. My fourth packet is the client hello. What's really cool is you can hover over the different parts of the hex, and it's going to annotate that for you. This is the record header part of it. This is the handshake header. This is the client version. I absolutely love this. I haven't memorized all this. In fact, I don't feel the need to memorize any of it if I have a good reference like this. Annotations, I've seen this before. This breaks out all that compact hex that we just saw into its individual fields and gives you a little more context around it. Thank you. I love this website. It is super, super cool. I'll click through the other ones. TLS 1.2, it's very much structured the same way. And then Quick as well. Quick is a new one that he's added semi-recently. This is, I believe it's a free open source. I think you can go on his GitHub where he actually has the source code for this website on there. So anyone can make corrections or submit different features or suggest different protocols. So this is super, super awesome for learning a protocol. Or if you have an issue with TLS, for example, and you're trying to figure out what should be happening, pull up this website on your other screen and just walk through it. Super, super handy. All right, and I think my last one, since we're coming up to the end anyways, my last one is CyberChef. How many of you guys have used CyberChef before? Yeah, okay, a few hands. Awesome, awesome. So I think we're getting a pretty good mix of people who've used various different tools. This looks very unexciting. I mean, I don't know another way. It looks pretty boring. CyberChef is an online Swiss Army knife for data manipulation. I don't know if that's their tagline or not, but that's what the tool is. It was developed by the GCHQ, which is Great Britain's sort of equivalent to the NSA. And so again, let's be sensitive. Have our sensitivity awareness hat on. Anything that you're publishing on here, just assume that everyone can read. This particular one is hosted out of GitHub's web hosting platform, so all that data is going to GitHub. Every CTF I've ever been in, I use this. Almost every SOC analyst tool or platform, web-based tool, also has this baked into it. Anytime you need to extract things out of packet payloads, for example, an HTTP session that has been compressed with Z library, right? That becomes unreadable text. You can look at it in Wireshark, it's unreadable. Wireshark does decrypt it, it does extract it, expand it, I don't know what's the proper way to say that, expand that. But you can copy that and do that right here. This is called Cyber Chef. It's trying to take on the idea that you're a chef in the kitchen and you feed it some data. So I'm going to feed it like A, B, C, D, E, F, G, Tony. Oh, what is the thing here? Tony E is my hero. And then you can add different ingredients to create a recipe, like convert that to base 64. So it takes whatever you have in your upper right pane, runs it through the recipe, and outputs it in the bottom right pane. This is super, super cool stuff, because in this recipe portion, you can stack different data manipulation. You can go to base 64 and then to hex, and bake that again. You see my output changed again. You can do, there's even a couple of Easter eggs in here. I do like this one. This isn't an Easter egg, but I just generated a QR code based from this, converted to base 64, converted to hex, converted to QR code. So if you take a picture of this on the screen, if you open the camera on your phone, it will say Tony E is my hero in hex after it was converted to base 64. So actually, you won't be able to read it. So let's tell you what, let me get rid of those. Now, if you do it, it will say Tony E is my hero. So I just took part of the recipe out, it changed the QR code, and is giving us new data. Super, super cool. I think there's one here called XKCD, the random number generator. You guys know the XKCD random number generator? It's always the same number, no matter what you put, because it's a funny comic. You can give it any data, it will always put out 4. All right, but anyhow, I love this because whether you're working with packets, whether you're working with data, whether you're working with drive encryption or any sort of data manipulation, like a lot of times when I'm having to figure stuff out in PyCharm, I'll just use this tool. It's an awesome way. You can also, I want to show you, it's not just text data. You can grab anything. Let me just throw this to the side. I want to get to my desktop. I just want to grab. Are you hungry? Oh, all right, this is great. Oh, you guys are going to love this. Okay. This is a picture of me and my brother when we were little kids. This past Thanksgiving, I remade this picture. All right. I know this is silly and really not interesting to packets, but for that tool, CyberChef, I'm trying to do this quickly. I know I'm just over time, and I'm sorry. I just want to be able to show you that you can take binary data files and drop them in and manipulate them. So maybe there's some sort of steganography hidden in that data image, right? You can start to build the recipes for that. In fact, there's a couple of security analysts out there where CyberChef is their specialty, and they write tons of recipes for different data to break down. And I recommend everyone give it a try. Just bookmark these websites, put them in your bookmark bar, and use them whenever convenient. You'll definitely, they're in mine already. Guys, that's all I have. That was 10 things. I hope you loved it. Oh, wait, let me get one more in, I swear to God. This one is tcpdump101.com, tcpdump101.com. You can actually right-click, do view source, and save this to your desktop and launch it locally. You don't actually have to do this one online. This helps you build packet captures, whether it's an ASA, a checkpoint, FortiGates, or TCP dump. So like people need to help build BPF filters. You can just start answering questions. What's your interface? ETH0. What kind of PCAP? Don't resolve host names. Link layer, okay. Give me the quick display, BGP, output file options, and then you can come over here and actually build your filter. I want to do a specific VLAN. What's the VLAN ID? 6. Okay, add filter below. Next one, I want to do source only, source or destination. So what it's doing is it's building your filter up here at the top, becomes your TCP dump command. Super, super easy, super awesome. Sometimes I can't remember all that information, those BPF filters. So I'll come here and do this. And also, it was a buddy of mine made this site, and you can run it locally. So I think that's super cool for those environments that don't have internet access. Throw this on a thumb drive, put it in there, and you can always have a handy reference for building TCP dump BPF filters. That is all. Thank you.